And the question is, a pyramid with vertex O stands on a square base A, B, C, D, and OA is equal to OC is equal to OD is equal to AB is equal to 5 centimeters. Calculate the height of the pyramid, the volume of the pyramid. C, the angle between OA, OAB, and the base. D, the total surface area of the pyramid. Now, let's have our calculation. So let me draw a square. In fact, because it stands on a pyramid, the way it will be drawn, you can't have a square like this drawn, like it's very difficult for a drawing. So that's how I've drawn this. This is a square. Here 5 centimeters, 5 centimeters, 5 centimeters, 5 centimeters. But the question says a square base OA. Okay, so if this says stands on a square base A, B, C, D. So A, B, C, D. Now, okay. Let me finish. This is the height of the pyramid. The height will meet the diagonals, the intersection of the diagonals. This is the height. The height will meet the diagonal at this point. So this A, B, C, D. This O, the vertex. Now, the question says OA. Where is OA? OA is also 5 centimeters. Is equal to OC. Where is OC? OC also 5 centimeters. OD. OD also 5 centimeters. This also 5 centimeters. Then AB. AB, because this height is same as this height, is same as this height. But the way it is drawn, because this three-dimensional object that is drawn like that. So that's how you see it. Now, the question says you should calculate for the height. This is the height of the pyramid. This is the height each of the pyramid. And now, this is a square base. So, a square, each corner is 90 degrees. This one is 90, here is 90, here is 90. You should know a square. And this one, this height divides AC into 2 equal parts. So let me name here F. So AF is equal to FC. Now, if I know AF, I know this side to OA, I can use Pythagoras Theorem to calculate for the height OF if I know AF. How do I get to know AF? AF is half of AC. So if I take this triangle out, this right triangle, with here A, C, B, with here 5 centimeters, here 5 centimeters. Then I can use Pythagoras Theorem. From Pythagoras Theorem, AC squared is equal to AB squared, which is 5 squared, plus BC squared, which is 5 squared. So AC squared is equal to 5 squared is 25 plus 25. AC squared is equal to 50. So how do I get AC? AC is equal to root 50. AC is equal to 7.071. Now, as I've indicated, that AF is half of the AC. So AF is equal to half AC. So AF is equal to half 1/2 times 7.071, which means 7.071 divided by 2 will give you AF. So my calculator, 7.071 divided by 2, and that gives you what? That gives you AF is equal to 3.5355. So which is approximately equal to 3.536. So this is the length of AF. Having gotten AF, I can pick triangle OAF out. So that triangle will be like this. OAF, with AF being 3.536 and this one being 5 centimeters, and the H here, which we have been asked to calculate. Now I can use Pythagoras Theorem. That's what I'm supposed to do. And from Pythagoras Theorem, the hypotenuse squared, because this height is perpendicular to the diagonal. The hypotenuse squared, which is 5 squared, is equal to 3.536 squared plus h squared. So that this one will be 5 squared minus 3.536 squared will give what? 5.536 squared. 12.503 is equal to h squared. Not so? This one is 25 minus 12.503 is equal to h squared. 25 minus that. 25 minus 12.503. 25 minus 12.503. What do you get?
12.497.
So this one will give us 12.497. So h squared is equal to 12.497. So what do? You square both sides. So h is equal to square root of 12.497, and h will be equal to 3.535. That is the square root of the 12.497. So this is the height of the pyramid. So A, we are finished with the A. The height of the pyramid is 3.535. That is great. Now let's go to question B, the volume of the pyramid. Now since I know the height, I can calculate for the volume of the pyramid. Now, let me clean this part. Good. Volume of the pyramid. Volume V is equal to base area times height. That's how to calculate the volume of every three-dimensional object. Is the base area times height. And this one is 1/3. 1/3 the base area times height. 1/3 times the base area times height. That's 1/3. And the base area, what is the base? The base, this pyramid stands on a square. So the base area should be the area of the square. So V is equal to 1/3 times the base area. Square is length times length, or L square, which is 5 times 5, times the height, which is 3. In fact, this is question B, 3.535. So the volume is equal to 1/3 times 25 times 3.535. So press 3.535 times 25. What do you get? 3.535 times 25. What do you get?
88.375.
So we divide it by 3. Divided by 3, what do you get?
29.
29.4583. So V is equals to 29.458. If it is centimeters, it should be what? Cube, because it is volume. So this is the volume of the pyramid. This is the volume of the pyramid for B. And now, see the angle between OAB and the base. Let me clean this aspect, this part too, and go for question C. Question C. Question C. The angle between OAB and the base. OAB and the base. You see that? So this will be the angle. Let me use a different marker. OAB. So it will be on the B. So this one will be the angle OAB and the base. You see, this is the height of the pyramid. Now, this is also the base. So what that means is that this one, the angle will be in the middle. But you see that when I draw this, if you look at it, you may think that this is more than 90 degrees. You see, you think that because this is a three-dimensional object. From the base, the center of the square, that's where the diagonals will meet, to AB is just a straight line, which will create an angle of 90 degrees. It won't be like this. If you do the practical way, you see that it will be this. And this. So this height is known already. This distance is not known. If it were to be the angle between OBC and the base, it would have been this, and it would have been an angle like this. It would have been this angle. But this is not what they are asking for. Now they are saying the angle between OAB and the base. So it should be this angle. See that? This angle. Let me make this angle theta. So we have the angle theta. But we know the height, this height. But we don't know this one. But if you have a square, like this, you have the diagonals. From this to this place, this to that, is the same as from this place to this place. It is the same as half of this place. So that is how it is. So this one is half of AB. Half of AB. So this distance, from this distance here to here. So if this one, triangle OF, let's make it OF E. Let's make it E. FE is half AB. Just like FE. This should have been the F, this should be the E. Should be half AB. So half AB, let me draw that triangle. That triangle will be this. With here 90 degrees. With here OE. With here F. Here will be half of AB. AB is 5. Half of 5 is 2.5. And the angle here is theta. That's the angle they are asking us to calculate. Half of 5 is not 2.5? Yes. Then the height of the pyramid is 3.535. So what you do is that, to get the angle, this opposite over adjacent. Opposite over adjacent. So we use tan. So tan theta is equal to opposite 3.535 divided by 2.5. Tan theta will be equal to. So 3.535 divided by 2.5
1 point.
will give us 1 point what? 1.414. Are you sure? 3.535 divided by 2.5. Okay, so if I want theta, what do we do? Theta is equal to tan arc or tan inverse of 1.414. And theta will be equal to did you press shift? Then you press the angle. What do you get?
I got
54.
54.73.
15. Okay, so theta is approximately equal to 55 degrees. So the angle is 55 degrees. That is the angle. Now, the next question is that we should calculate for the total surface area. Not so? Now let's calculate for the total surface area. We see that if you draw the net of this figure, the square pyramid. Let me draw the net of the square pyramid here, then you will understand it properly. Because you know the height. Let me draw the net of the square pyramid. Let me clean this part. Let me draw, because we had the height to be 3.535. If I draw the net of the square pyramid, it will be like this. But these four triangles are congruent, meaning they are the same. They can lie exactly on each other. These triangles are congruent. They can lie exactly on each other. So the total surface area is the area of the net, the sum of the areas of these four triangles and the area of the square. So if you get one triangle, you multiply by 4 because the triangles are of the same area. So let's pick this. I can pick triangle OAF. Triangle OAF. If I pick triangle OAF, it will be like this. OAF. With the height being 3.535. With AF, we calculated AF. Do the AF for me. 5 square plus 5 square, which is 50. Square root of 50 will give us what?
7.07.
7.071. Then divided by 2 will give AF, which we calculated previously, but since I have cleaned it,
It's 3.535.
3.535. Fine. Can't we calculate the area of this? We can calculate the area, which is half area of this equals to half times base times height. This is the height, this is the base. Not so? So it should be half times 3.535 times 3.535. So are you saying that the height and the base of the triangle are the same, the height and the base? Okay, continue.
So 3.
No, you said square root of 50, what do you get? 5 square plus 5 square, which is, this is 25 plus 25, no so. Square root of 50 you had?
Square root of 50 is 7.
Okay, then divide by 2, no so.
Yes, sir.
Okay, multiply these two. Then divide the answer by 2. Multiply this.
3.5
Squared. 3.535 squared. What do you get?
12.496.
12.496. Then you divide the answer by 2 to get the area. Area is equal to 6.2428. So area is approximately equal to 6.25 centimeters squared. That's the area of the triangle, also.
Yes, sir.
So we have 4 of these triangles. So what about area of the square? Area of the square.
Area of the square 5 times.
That's we are cutting C. Area of the square will be equal to 5 times 5, which is 25 centimeters square. But this is one of the areas of the triangle, so total surface area is equal to 4 times 6.25 plus 25, because this is one of the triangles. You multiply by 4. What do you get?
Got one.
Thank you very much for watching. You see any Abdulrazak Ninja Man.